Okay, so number 5 is special, just like number 4. So let's start off treating it normally, and then I'll talk about what we have to do to account for the fact that it is special. So we only know one angle. We know side A and angle A, so we're going to set up 54 over sine of 40 is equal to 62 over sine of B. So let's find angle B. So I'm going to say 54 times sine of B equals 62 times sine of 40, and I'm just going to get my answer. So I'm going to take 62 times sine of 40. I'm going to divide by 54. I'm going to take sine inverse. So I get that B is equal to 47.6 degrees. Okay, so let's talk about this problem. And there are pictures in your book that you can find that I don't think I would be very good at drawing to represent this. So it could be that angle A is 47.6 because the sine of 47.6 is this 62 sine 40 divided by 54, which is, so sine of B equals 0.73, 80, etc. And so B could be 47.6, but B could also be 180 minus 47.6, which is 132.4, because the sine of 132.4 is also this same number. I rounded, so it's going to be approximately, but it's a little off, but it is. So B could be 47.6 or B could be 132.4. So I'm actually going to have two different triangles that can be created here. So let me talk about something that did not come up in number 3. The fact was I found B was 31.5, and that was all that it could be. Because if B could also equal 180 minus 31.5 is 148.5. Well, let's think about that. If angle B is 148.5 and angle A is 43 and angle C is whatever's left over, 180 minus 43 minus 148.5 is negative 11.5 degrees. So that can't happen, which means I don't need to worry about this. So there's only one possible triangle that has 3 angles. But in this case, let's look at A being 40 and B being 47.6, and then let's look at A being 40 and B being 132.4. So if A is 40 and B is 47.6, 180 minus 40 minus 47.6, C is 92.4 degrees. And this is a triangle because all 3 angles are positive. And then if B is 132.4, then 180 minus 40 minus 132.4 is 7.6. So it's a very small angle, but it is still an angle. So I've actually got 2 different possible triangles to solve. So I have that it could be that B is 47.6 and C is 92.4, or it could be that B is 132.4 and C is 7.6. In either case, I'm not done because I don't know side C. So I need to find side C in both separate cases. So let me write over this info. So A is 40, B is, I already forgot. I'm going to have to go back and forth a lot. 47.6, C is 92.4 because I'm looking at my calculator. And then over here, A is 40, B is 132.4. I'll just look at my calculator. C is 7.6. Okay, in both cases, A is 54 and B is 62. If you research law of sines ambiguous case, you can see some pictures describing that these 2 triangles do both exist. And so I need to find side C in both cases. So on the left here, I rounded 47.6, I believe. So let's use A. So let's use what I'm given, which is 54 over sine of 40 is equal to, if I'm trying to find C, over sine of 92.4. So I'm going to cross multiply, I'm going to divide. So 54 times sine of 92.4 divided by sine of 40 tells me that C in this case is equal to 83.9. And then on the other triangle, so this is a completely separate triangle, if I set up 54 over sine of A, which is 40, equals C over sine of C. In this case, C is 7.6. So I'm still going to cross multiply, but I'm going to take 54 times sine of 7.6 and divide by sine of 40 and get that C is 11.1. So this triangle on the left exists. I could draw it. This triangle on the right exists. I could draw it. So I have two separate cases. So when you are only given one angle, you have to check to see if you possibly have two triangles. If both triangles have only positive angles, then you have two triangles. If you have a situation where you're only given one angle and you find the third angle, or if you find that the other angle by taking 180 minus creates a negative angle, then you only have one triangle. So you can have one triangle, you can have no triangle, or you can have two triangles.